Japan Revitalization Plan. Japan becomes an exporter of energy resources, saving the world with water and energy. With sufficient energy, you can be self-sufficient in food. Coal, oil, and natural gas are indispensable in today's world. The reason is that it can be stored for a long time. It can be exported to all over the world. Large-scale supply is possible. And so on. Japan relies almost entirely on imports from overseas for these. In recent years, when decarbonization has been called for due to global warming, did you know that Japan possesses something that will be a game changer for this energy? I am amazed at how few Japanese people are aware of this fact. It's the ocean. Japan's exclusive economic zone is approximately 4.09 million square kilometer, which is the sixth largest in the world. There are 1.8 quadrillion tons of magnesium in ocean, which covers about 70% of our planet. In Japan's exclusive economic zone, 4.1 billion tons of magnesium are contained in seawater at a depth of 1 meter. The amount of electricity generated from this magnesium is 28,000 terawatt-hours, which is almost equivalent to the world's total annual power generation of 27,000 terawatt-hours. Moreover, did you know that there is a Japanese who has demonstrated the technology to reproduce this and use it over and over again? In 2004, Professor Emeritus Takashi Yabe of the Tokyo Institute of Technology proposed a magnesium recycling society in which magnesium is extracted from seawater, magnesium is produced using natural energy, and spent fuel is recycled. In 2006, he published the possibility of a magnesium recycling society concept with experimental results in Applied Physics Letters, the world's highest authority on applied physics. In 2009, Professor Yabe was introduced as one of Heroes of the Environment by Time magazine. It was hoped that the Magnesium Energy Society concept would make a significant contribution to environmental problems. In a magnesium recycling society, magnesium is first extracted by desalination of seawater from the sea, which contains 1.8 quadrillion tons of magnesium. Next, magnesium is burned instead of coal in thermal power plants to generate electricity, and it is also used as a fuel cell for electric vehicles and electric airplanes. The exhausted magnesium fuel is recycled and broken down into magnesium atoms by lasers converted from natural energy such as sunlight, wind, and geothermal energies. All renewable energies such as solar and wind power are unstable in supply and cannot be stored or transported. If all this energy can be converted into magnesium and stored, it can be exported overseas. If this technology can be operated jointly with other countries, a huge energy supply organization will be created. Is that really possible? The answer is yes. The technology for extracting salt and magnesium from the sea is almost complete. In 2019, the Ministry of the Environment of Japan estimated the potential of offshore wind power in Japan. It is 1,000 terawatt-hours for a 30 km restriction from land, and 10,000 terawatt-hours for no restriction. This is about one-third of the world's total electricity generation of 27,000 terawatt-hours. In addition to this, there are ocean currents around the Japan archipelago, and ocean current power generation using these currents is also being considered. Additional energy sources, such as geothermal and photovoltaic power generation, will also be added to this. How far have these technologies progressed? In a seawater desalination device, magnesium is extracted. Separation of magnesium by laser. Magnesium-based fuel cells. Magnesium-fueled thermal power plants. I would like to introduce the current situation. Brand new seawater desalination and sewage treatment equipment has been proposed and manufactured. No membranes used. It does not produce wastewater that pollutes the environment. Less energy? Operate on solar heat and waste disposal heat. We get salt from seawater, magnesium can be extracted. We bought the small sewage treatment equipment shown on the left to the sewage treatment plant, treat the water from the treatment plant as in the PET bottle on the left, and make pure water like the PET bottle on the right. In addition, the salt in the seawater has been completely removed. Experiments using this seawater desalination device to extract tritium from nuclear power plants and experiments to remove fuzz are also successful. In 2008, we succeeded in reducing the energy required for evaporation to 1/4 by making this device 4 stages. Professor Yabe did not place these 2 rows vertically, but horizontally as shown in the figure in the middle. The details are a bit difficult to explain, but the general idea is as stated. Furthermore, as shown in the figure on the right, the propellers were arranged side by side to achieve an ultra-multi-stage. Successful separation of magnesium by laser. Laboratory-level experiments were successful. Using a laser, we achieved purity of 96% equivalent to that of the conventional pigeon method, which uses 10 times more coal than magnesium, and achieved 4 times higher efficiency. Even taking into account the price of the laser, it can be manufactured inexpensively.
In this experiment, separated magnesium is recovered. Magnesium oxide and a copper sheet are placed inside the vacuum chamber and are irradiated with a laser beam. The magnesium oxide is instantly vaporized and separated into magnesium and oxygen. Only the magnesium adheres to the copper sheet. A white substance is coated on the copper sheet. This is magnesium. When a piece of the sheet is cut off and connected to electrodes, a chemical reaction occurs and electricity is generated. Thus, magnesium can be used as a battery. We have developed new technology that opens up major new possibilities.
Magnesium-based fuel cells. Small units are now in mass production. A small fuel cell with 9 times the capacity of lithium-ion batteries has been completed. A disk-type fuel cell is closest to practical use. The video shows a simulation of the battery operation. The pink part is the magnesium plate, the triangular pyramid part is the battery reaction chamber. Magnesium fuel enters the reaction chamber while rotating, and comes out. The magnesium battery corresponding to Nissan Leaf is 24 kilograms, which is 1/10 the weight of a lithium-ion battery. The size will be about 60 centimeters in diameter and 50 centimeters in height. A small unit of about 6 kilograms is easily replaced, and is inserted into the battery slot at any time. If you use 6 pieces, it will be 36 kilograms, 54 kilowatt-hours. The fuel is magnesium with a thickness of about 1 millimeter, so it will not burn easily even if it is lit, so it is extremely safe and will be able to be sold at convenience stores. Thermal power generation that burns magnesium instead of coal. Laboratory-level experiments are successful. When water and magnesium are mixed and reacted, they produce combustion energy equivalent to that of coal-fired power plants. Moreover, it does not generate any carbon dioxide. The high-temperature steam generated turns the turbine to generate electricity. Magnesium is also an excellent hydrogen carrier. If magnesium burns with water, 1 kilogram of magnesium can generate 83 grams of hydrogen. Only the difference between power generator and hydrogen generator is the size of the magnesium. Magnesium larger, reaction becomes moderate. This can be used for hydrogen fuel cell. When Yabbe proposed this concept 20 years ago, only a few people agreed with it, but now, 20 years later, more and more people are convinced that it is a technology that the world really needs, and the possibility of a magnesium recycling society becoming a reality is increasing. Hopefully the number of people who agree and want to contribute in some way will increase, and with the support, spiritual and technical cooperation of as many people as possible, then Japan will become the world's best technological nation and expand this circle so that it can contribute to the world.